Okay, good day, grade nines. This is Mr. Smith, and I'm going to show you a third method for solving this question that would be found as part of your homework, MathLinks textbook, page 327, question 90. So previously, I showed you just how to solve it the way the question is written. Okay, so you've got your two constant terms, you got your two variable terms. I had you change this to a improper fraction. But basically, you accepted the question the way it is, and you just solved it. The second method, I had you change everything to decimals. The third method is a kind of a neat one. Okay, I call it inflate the balloon. Okay, or sometimes I call it the blow up. So you're gonna blow up this question. Okay, and here's how you do it. You use what's called the lowest common multiple. All right, and we've talked about this in class. So the lowest common multiple kind of works on this basis. All right, I'm just going to grab a cue card here, kind of on the side, and let's just go back to very basic addition facts. If you have this, say like a 2 plus 3, okay, let's try that again. 2 plus, looks like I was going to write multiply there. 2 plus 3 is equal to 5, right? And so, of course, it goes without saying that's 5 is equal to 5. We could start with this question, right? And we could, if we wanted to, multiply it by, say, a 10. And if you remember how to use your distributive property, this would be 10 times 2 plus 10 times 3 plus 10 times 5. Well, 10 times 5 is 50. 10 times 2 is 20. 3 times 10 is 30. And essentially, you get still an equality. Now, you know, of course, that this is not the same question necessarily, but that doesn't matter. And a lot of students don't realize that. Okay, like some students will say, but Mr. Smith, you started out with 5 equals 5, now you have 50 equals 50. But the equal sign, okay, remember the equal sign only cares about truth. It doesn't matter. So this is where this rule comes from of whatever you do to one side, you do to the other. You may have heard your teacher say that. The point is every mathematical truth simply requires balance. In other words, you want to make the equal sign happy. The reason that's important is because let's say you have a question that has lots of fractions and denominators, okay? So you look at this question and you're like, gee, I'm not too fond of fractions. Well, there is a way to make this question. Now over here, just to grab this back, I chose to make this question 10 times bigger. Why? Because I like the number 10. It's easy to work with. But here, you're going to be very deliberate. In other words, you're going to be very intentional. You're going to think carefully. And you're going to look at your denominators. And you're going to start remembering, or if you need to list them out, okay, if I start counting by 2s, because 2 is one of my denominators, okay? Here's the 2. All right, if I count by 2s, all right, and now if I count by 4s, what is the first number they have in common? So 4, 8, 12, 16. Well, that should be fairly obvious. The lowest common multiple they have is a 4. So here's what we're going to do. Okay, we're gonna inflate this question. We're going to make this question 4 times bigger. And you can do this with any question that has fractions. All right, so let's see what that looks like. So first of all, I am going to convert this to an improper fraction. So 5 over 4m, okay? 5 over 4m plus 1/2. This is the only alteration I'm making, is equal to 7 over 4m. This is already improper, minus 1/2. And so now what I'm going to do is this. I'm going to draw some big brackets around both sides, okay? And I'm going to multiply everything on either side, both the left side and the right side. I'm going to multiply it by 4. I'm going to make the left side and the right side 4 times bigger. What does that look like? Well, you do have to be comfortable using the distributive property, okay? And by the way, your arrows, when you go on the right side, just because there was more room, there wasn't a lot of room to squeeze in the number 4 here, so I wrote it over here because the order of multiplication doesn't matter. Okay, one thing I'm going to have you remember, of course, is that every whole number is the same as that number over 1. So here's the result, okay? You have 4 over 1, and you're going to multiply it to 5 over 4, okay? And don't worry about the m. Right now, you're just trying to inflate this fraction to be 4 times bigger, okay? So you have to do it to everything on the left side, and you have to do it to everything on the right side. In other words, if you're going to make the whole equation 4 times bigger, everything must become 4 times bigger. So 4 times 1 using the distributive property, 4 over 1, 4 over 1 times 1/2. That's equal to 4 over 1 times 7 over 4, m minus 1/2 times 4 over 1, okay? So now you just get to multiply and simplify. So multiply, a little bit of a rhyme there, multiply and simplify. Okay, so I'm just going to adjust the camera down here so we have some room. Okay, so what does that look like? 4 times 5 is 20. 1 times 4 is 4. This is a really nice thing. You'll see, because we are going to multiply, but look, some of you can already see how this is going to simplify. 4 times 1 is 4. 1 times 2 is 2. Oh, that's a nice moment. 4 times 7 is 28. 1 times 4 is 4. Now, some of you advanced students know that you can pre-simplify. You can start crossing out common factors. Later on in higher math, you'll learn to just go cross out of 4, cross out of 4. We're not doing that right now. Let's just do the actual multiplication. Let's actually see what actually happens. So 4 times 1 is 4. 2 times 1 is 2. Okay? Notice I didn't change the operations, right? This is an addition, all right? This is a subtraction. They would really only change is only if in the case that I decided to multiply both sides maybe by a negative number. But I'm not really motivated to do that. Why not keep it simple? So this is, oh, I'm happy here and I'm happy here. This is the result of making this equation 4 times bigger. Now, you may not realize it, but it's the equivalent, I know it's off the page, but it's the equivalent of the original question. Notice my words. It is the equivalent. It's going to look different, but it is the equivalent. Equivalent is the key here. So let's simplify. Okay, so simplify means 20 over 4 is 5m. Okay, 4 over 2, just going to press the focus button here. Sorry about that. 4 over 2 is 2. 28 over 4 is 7m. 4 over 2 is 2. Now look at the happy spot we're in. We've got what? We've got all whole numbers. That is the point of multiplying both sides by a lowest common multiple. Okay, I'm just going to put it back up here. Using the lowest common multiple. What's the lowest common multiple between a 2 and a 4? It's a 4. So I'm going to multiply both sides by 4. Boom. This whole equality, this whole equation, both sides, everything, every term gets multiplied by a 4. Every term becomes 4 times bigger. Okay? Multiply it, then simplify. What's your result? Something that is very workable, because now you have whole numbers. All right, we got to get like terms together. So here's what I'm going to do. I'm going to add 2 to both sides, and at the same time, I'm going to subtract 5m from both sides. Okay? What happens? I get a couple of nice 0 pairs. Here's what that looks like. That becomes a 0 pair, and now my constants are all on one side. My variable term, my positive 5m, subtract 5m, that becomes a 0 pair. Now we're really into the game of solving and isolating this variable. 7 minus 5m is 2m. 2 plus 2 is 4. Divide both sides by 2. And I get 2 is equal to m. Okay, I'm a little bit off the page there. All right, and that's my solution. Okay? So, good times. So there are 3 ways, right? We did 3 methods. Okay? Number 1, we just accepted the question. Accept the question as is. In other words, we didn't alter it. We didn't do any shortcuts, cheats, tricks, hacks, whatever. We accepted the question as is. Do it. Okay? I'm just gonna do, right, the question as is. I'm just gonna deal with those fractions. Okay, method 2, all right, whoops, straighten that out, Mr. Smith. Method 2 was convert to decimals. Method 3, inflate or blow up your equalities, your equation. Inflate, blow up using the lowest common multiple. Okay, it really doesn't matter. It really doesn't matter which way you do it. Okay, you pick a method that you like. And by the way, the real secret to this game is sometimes this is the easiest, sometimes this is the easiest, sometimes this is the easiest. In other words, you should get good at doing all three, right? You should be aware of all three. You should practice all three. And there's going to be circumstances. In other words, there's going to be certain questions that are best to do this way. Just do the question. Just don't try to fool with it. Sometimes it might, like the decimals. And sometimes it might be just easier. This really works when you have multiple denominators. Like if you have if this question had a 2 here and a 3 and a 5 and a 6 or something, maybe it would have been easier to just blow up using lowest common multiple. Okay, that's it. I hope that helped, and we'll talk to you later.